Hi, I'm RL from MathinSG.com. In this video here, I will be going through the 2024 H2 A-Level Math Paper 1, question 11. And this question here is a differential equation question. Full work solutions can be found here at this website here, link in description below. So let's take a look at this question. A helicopter is hovering at a great height above the ground. A parachutist drops from the helicopter and his parachute is open. The parachutist falls vertically. At time t seconds after leaving the helicopter, he has fallen a distance of x meter. At this time, he has a velocity of v meter per second. The motion of the parachutist is modeled by the differential equation, where alpha is a constant. So use the equation v equals to dx dt to write down a differential equation in v and t. And this is only 1 mark. So we know that v is dx dt. So I have this equation here, right? So I know that here I can change it to v already. So if v is dx dt, so if I were to differentiate dx dt, I get d square x dt square, right? So, and d square x dt square is equals to dv dt. So I know this one, I can change it to dv dt. So in other words, right, I can write this equation as dv dt plus alpha v equals to 9.8. Next, you're given that dv dt equals to 5 when v equals to 2.4. Find the value of alpha. So basically just sub in these values. dv dt is 5. Then v is 2.4 equals to 9.8. So to find alpha is basically 9.8 minus 5 over 2.4, which gives us 2. Okay, so we have found alpha is 2. Next, let's move on to part B. It is given that the initial velocity of the parachutist is 0. So in other words, it's trying to tell us when t is 0, v is 0. So why we need it? Because later on, we will have some arbitrary constants. We need to sub it in to find what is the value of the arbitrary constant for your differential equations. You're asked to show that v equals to a bracket 1 minus e to the power bt, where a and b are constants to be found. So we need to make use of this equation that we have found, right? dv dt plus, I know alpha is 2, so it's 2v equals to 9.8. So I have dv dt plus 2v equals to 9.8. Okay, and I need to find what is v, right? In other words, I need to solve this differential equation. So what I'll do first is I will just bring my 2v over. Then I'll use variable separable method. So I will put everything with v to the side of dv, and everything with t, which is basically just a constant because there's no terms in t, okay, beside dt. So integrate this side will give me t plus c1. Here, integrate here will give me minus half ln 9.8 minus 2v, and I'll put a mod sign here. Next, I'm going to multiply both sides by negative 2. So I have this. So I have minus 2t minus 2c1. Okay, then I will let my c2 be equals to minus 2c1. So I'll erase this and then just change this to plus c2. Okay, because it's an arbitrary constant. 3 times an arbitrary constant is still an arbitrary constant. Minus 2 times an arbitrary constant is still an arbitrary constant. So I just change it to c2. So next I want to remove the ln. So to remove the ln, I'll put e to the power of everything here. Okay. So now I'll make v the subject. So 2v equals to 9.8 minus e to the power of minus 2t plus c2. So v is equals to, divide everything by 2 here, it will give me 4.9 minus 1 over 4.9 e to the power of minus 2t e to the power of c2. Okay, and I want to let maybe c3 equals to e to the power of c2, right? Because e to the power of an arbitrary constant is just an arbitrary constant. So I'll change this to an arbitrary constant, which I call c3. So I have v equals to 4.9 minus c3 over 4.9 e to the power of minus 2t. Next, I need to find what is c3, right? So I'm given that when t is 0, v is 0. So I know that, okay, c3 over 4.9 e to the power of minus 2t. Hold on a second. Maybe I do not want this to be c3. So I will just let c4 be c3 over 4.9. Okay. Okay, because maybe I should write it this way. So I would let e to the power of c e to the power of c2 over 4.9 be equals to c4, because e to the power of arbitrary constants divided by a constant is still an arbitrary constant. So I just let this whole thing to be an arbitrary constant. So as long as everything is an arbitrary constant, you can just change it to another arbitrary constant. Okay, so that's easier to work with. So I just change this to c4. Okay, then here is sub in t is 0. So anything to the power of 0 is 1, right? So I know that 4.9 is equals to c4. So c4 is 4.9. So v is equals to 4.9 minus 4.9 e to the power of minus 2t. Factorize out 4.9. So if I were to compare this with this, I know that my a is 4.9 and my b is minus 2. Alright, let's move on to part C. So in part C, you are told that the helicopter is at a height of 2,000 meters above the ground. Find the time taken for the parachutist to reach the ground. So this has something to do with distance, right? So very likely we need to deal with x instead of v. Okay. So what is x? Well, if you look at the first part, right, x is essentially the distance fallen. So if a parachutist is at a height of 2,000 meters above the ground, okay, if you want to find the time for him to reach the ground, he needs to travel through a distance of 2,000 meters, right? He needs to travel downwards by 2,000 meters. So we need to find what is t when x is 2,000. Because take note how they define x. X is the distance fallen. So at the start, the distance fallen is 0, right? When he reached the ground, the distance fallen should be 2,000 meters. Okay, so we need to find what is t when x is 2,000. So in order to do so, we need an equation in terms of x and t. So how do we do that? Well, we already have an equation for v, right? And v is dx dt, right? Okay, I expand this out. Okay, I use this one instead of this because this one is easier to integrate. Okay, how do I find x? Well, I just integrate 4.9 minus 4.9 to the power of e to the power of minus 2x with respect to t, right? So we know that when t is 0, x is 0, right? So I know 0 equals to this 4.9 times 0 is 0. Then this is e to the power of 0 is 1. So it's 2.45 plus c. So c is negative 2.45. Okay, so now I know that x is equals to 4.9t plus 2.45 e to the power of minus 2x minus 2.45. So next, what do I need to do? When x equals to 0, I need to find t, right? So 0 equals to 4.9t plus 2.45 e to the power of minus 2t minus 2.45. Okay, this one has t as well as e to the power of minus 2t. Okay, no way you can solve it algebraically. Okay, so use your GC. Okay, sketch out this graph y equals to 4.9t plus 2.45 e to the power of minus 2t minus 2.45. Then look for the x-intercepts. Okay, or you look for your GC says the 0 values. Okay, use your GC to solve, and we are only interested in values of t greater than or greater than 0 because Because why? Because this is a time, right? T is time, so we only want positive value. So by GC, okay, you'll notice that T is equals to 409 when rounded off to 3 significant figure. So this is the answer. You'll notice that at first you'll notice that it doesn't have any intersection. You have to increase your windows, or you need to scale, or you need to increase your windows and your values of X in your GC, okay, until you get it, because you notice that curve is sloping towards the X-axis, right? So you need to move more towards the right. All right.